Hey students, thought I'd make a little video about problem 60 here in IM4. I've got a really cool problem where we basically are going to prove two very famous identities in trigonometry. So the first thing that's useful to think about is just what is an identity. So if you know what it is, great. If you don't, maybe do a little research on that. What's the difference between identity and an equation? The next thing is to actually get in here and notice how to visually prove these identities. So I think this is a really cool statement too. It's like, why do we even do this? Well, knowing identities in trigonometry and algebra and math in general allows you to simplify or expand expressions. And a lot of what we do in math is trying to be creative in viewing the expression and interpreting the expression in front of us. So by knowing these identities and knowing where they come from, you're actually developing your fluency and vocabulary with math. So what I really like is we've actually improved this problem. We used to not have this diagram or kind of this step-by-step scaffolding for this proof, and I think it's really helpful. So make sure you go through this step-by-step. I actually argue that this maybe is the first one you should try and prove, and then maybe come to this one second. So we're going to work with sine of alpha plus beta. So I'm just going to kind of get this started to hopefully help it kind of make sense to you, and then you'll be able to finish it. So what's nice about having this diagram is it's really well labeled. It has color. It's kind of color coded. It's always smart to also include some labels at these vertices so that I don't know why I'm doing my alphabet incorrectly. So we can all talk about the same thing, right? Yes, we could talk about the red segment, but saying segment EF is going to be even more precise. So we actually want to find expressions in terms of trigonometric functions. So we're going to start with this red segment. So I need to come up with some kind of expression that gives this red segment. And I'm just going to go step by step, like these are check boxes, to do each of these one at a time. And I encourage you to do that as well. Well, I see that that's in triangle AEF, and triangle AEF is a right triangle. This is 90 degrees. So angle beta is going to be my reference angle. And I notice that the red segment, or EF, is opposite. And I know the hypotenuse is 1. So using the sine function is best here. So I could say, I could show that, okay, sine of beta should be equal to the red segment, which is EF, over 1. Well, the reason I just wrote this right away is because I knew that this was going to simplify to just EF. I could multiply 1 to both sides, I suppose. When our hypotenuse is 1, the segment is simply the value of the ratio. So sine beta gives that red segment. So I actually think that's all I want to tell you, because I think from there you guys can maybe find the green. For C, it's really important to think about alternate interior angles. If you want to do some research on that, that could help to find another. Here's one location of A plus B. There's another spot on this diagram that also has the angle A plus B, or alpha plus beta. And then I think you'll be able to tie this all together. All right, have fun.